Hey everyone, so we're still on Unit 7, Solutions, and we're going to talk about our next lesson, Lesson 8, calculating concentration and also colligative properties. First, I want you to jot down any questions that you might have about this unit, bring them to class, be prepared for that. Okay, and the objectives in this lesson will, you will learn how to use formulas from Table T to calculate the concentration in various ways. So there's 4 different ways to do this, and you will determine colligative properties of solutions. There are 2, and they have specific names. All right, so let's start with our notes. So calculating concentration now, these brackets are here for a reason, okay? When we're trying to calculate concentration, when something is in brackets, we are telling someone that this is concentration, okay? So when anything is in brackets, we're talking about the concentration, of course, unless it's an electron dot diagram. Don't get that confused. Okay, so calculating concentration, we're going to use all of the formulas that are found on Table T. Remember, solutions are homogeneous mixtures. They're aqueous. Their compositions can vary, though. It is therefore important for chemists like us to know the composition of a solution. Chemists use the following methods or formulas to specify concentrations, whether they're in parts per million or by mass, molarity. Basically, the relative amount, here's an example, relative amount of salt in a solution of salt water. How many? Parts per million. What is the concentration? So the higher the concentration value is, the more solute that is dissolved in the solution. Remember, concentration is directly related to how much is dissolved, not what settles to the bottom, okay? That does not contribute to the concentration. So molarity, the formula for molarity from Table T is equal to, all right, so molarity is equal to the moles of the solute divided by liters of solution, and I'm going to abbreviate that, remember, SOLN. Okay, now if it's not in liters, remember you have to convert to liters. If it's milliliters and you're converting to liters, you must multiply by 1,000 because milli is equal to 1,000. Okay, so for example, let's use this. What is the molarity of a solution that contains 4 moles of sodium hydroxide in a 0.50 liter solution? So they tell us the liters of the solution and they give us the moles of the solute. So we just set it up. 4.0 moles divided by 0.50 liters. Plug that into our calculators and we get 8.0. And we can say molar, okay, molarity, or the same thing as 8.0 moles per liter. Same thing, moles per liter. All right, the next formula, parts per million, basically used for larger amounts of solvent. So oceans, lakes, rivers, okay, things like that. We use parts per million because it's such a large volume. So the formula for this is going to equal the mass of the solute over the mass of the whole. And then we have to multiply this by 1 million, okay, 6 zeros, 1 million. That would give us parts per million. So for example, we have 0.0043 grams, that's a mass, of oxygen can be dissolved in 100 milliliters of water. Now the temperature doesn't have anything to do with anything here, so we're going to express this in terms of parts per million. All right, now we have to remember 1 gram is equal to 1 milliliter of H2O, okay, based on its density. 1 gram per milliliter is its density, and that's where we get the mass from. So 100 milliliters is going to equal 100 grams. So I'm going to just put this here so you know that 100 milliliters is equal to 100 grams of H2O. So when we set this up, we have the mass of the solute, 0.0043 grams divided by 100 grams of water, multiply by 1 million, and we get 43, and the units are ppm, parts per million. Okay, percent by mass and percent by volume. You guys should be familiar with these, okay? Now percent by volume is the same thing as percent by mass, but we're using volumes. All right, so this is going to be the mass of the part divided by the mass of the whole multiply by 100. Okay, and I'm just going to skip over here so we can fill this in here too. So volume of the part divided by volume of whole multiplied by 100. Remember, percent, we multiply by 100. So what is the percent by mass of sodium hydroxide if we have 2.5 grams of sodium hydroxide and it's added to 50 grams of water? So this is going to be the mass of the whole, okay, and this is the mass of the part because we have 50 grams of water and we also have 2.5 grams added to that. All right, so we have to add it up to get the mass of the whole. So the mass of the part is 2.50 grams. Okay, that's the part. Now we add that to the 50. So the mass of the whole is 52.50 grams. All right, we divide that and then, then multiply by 100 in our calculators and we get 4.76%. Okay, now we'll do percent by volume. What is the percent by volume of alcohol? If you have 50 milliliters of ethanol, it's diluted with water to form a total volume of 300. They're telling us the total. So the total is going to be 300 milliliters. That's the volume of the whole, okay? And they tell us they add 50.0 milliliters. So that's the mass of the part, or the volume of the part. So when we divide that out, and then we multiply, keep doing that, multiply by 100, we get approximately 16.7%. All right, so next page, okay? Any questions about this, please ask me in class. I've showed you how to do this, and then we're going to apply it in class. So next subject is the colligative properties for electrolytes. So electrolytes are substances that produce ions. Okay, we're going to add that in here. And it is based on the number of particles, okay? So colligative properties have to be determined based on the number of particles of that are in the solution, okay? Number of particles. So a substance that produces ions when dissolved in a solution, these are going to be ionic compounds, all right? Because the ions are free to move around, they're mobile, and in the solution, it is able to conduct electricity. These are especially salts, okay? They're called salts. So electrolytes are salts, and it is the same concept as mobile electrons in metals, but not the same thing. Let's not get this confused on the reagents, okay? Mobile electrons, yes, they can produce electricity because they're mobile, but it's not the same as an electrolyte because an electrolyte is a compound, okay, not just a metal by itself. So when a solute is dissolved in a solvent, the solvent molecules surround the particles of the solute, and this is going to cause the boiling point and freezing point of the solution to change in a very specific and predictable way. So what we look at is just a little scale here. Boiling point elevation. So this is one colligative property. This is the first one. The boiling point elevation is when the boiling point increases as you add solute. All right. So for example, we add salt to water. It will allow you to boil pasta at 102 to about 103 degrees Celsius, and it cooks it faster. Okay, meaning that you don't actually boil faster, but it's going to cook it for a faster period of time, and therefore you don't have to sit there and wait as long. So freezing point depression is the other colligative property, and the freezing point depression decreases, or the freezing point decreases when a solute is added. So when we put salt on roads, we cause the ice to melt. And you guys read about this, and we had this discussion in class. So it's going to drop the freezing point below 0 degrees. We know the freezing point is 0. But when we add a solute to that, like salt, for instance, it's allowing more ions into the solution. Okay, now on the roads, and it's going to make it, it's going to take longer for it now to freeze because all of those ions need to freeze as well. Okay, so that ends lesson 7. okay, or lesson 8, I'm sorry, lesson 8 for the unit. And if you have any questions on these, but basically they go hand in hand. When we add a solute, the boiling point is going to go up, and as we add the solute, the freezing point goes down. So they go together based on number of particles, therefore colligative properties. All right, thanks for listening, guys.